Dear students, welcome to the online class. I am Dr. S.S.C. Hiremat. In this video, you are going to study about the application of Schrödinger's wave equation to a rigid rotator. Rigid rotator means, suppose M1 is one particle and M2 is another particle. These two are bound by a rigid bond. Suppose C is the center of gravity. M1 is the mass of particle M1. Small m2 is the mass of particle m2. The distance between C and m1 is r1. Distance between center of gravity and m2 is r2. The total distance between these two particles is equal to r. Now this rotates about this center. During rotation, the distance between these two particles remains constant. Therefore, it is called a rigid rotator. Okay. Suppose M1, M2 are two particles with masses small m1 and m2 respectively. C is equal to center of gravity. Distance between M1 and C is equal to R1. Distance between M2 and C is equal to R2. So that total distance between M1 and M2 is equal to R1 plus R2 equal to R. During rotation, distance between two particles remains constant. That is R equal to constant. That is the bond between M1 M2 is rigid. So it is called rigid rotator. Now let us derive the expression for the reduced mass and moment of inertia. Suppose moments about C, that is M1 R1 equal to M2 R2. Suppose this is equation 1, and from the definition, R1 plus R2 equal to R. That is R1 R2 equal to R minus R1. Suppose this is equation 2. From equation 1 and 2, From equation 1 and 2, we may write M1 R1 equal to M2 R1. That is M1 R1 plus M2 R1. M2 R1 is equal to M2 R. Therefore, R1 equal to, you may take R1 common, that is M2 R divided by M1 plus M2. Similarly, R2 we may derive M1 R plus divided by M1 plus M2. M1 plus M2. Okay. Now suppose these are equation 3. The moment of inertia. The moment of inertia I is equal to M1 R1 square plus M2 R2 square. Okay. Then suppose this is equation 4. From equation 3 and 4, from equation 3 and 4, we get M1 I equal to M1 and R1 equal to M2 R divided by M1 plus M2 whole square plus M2 R2 equal to this M1 R divided by M1 plus M2, this is square. Okay, that is I equal to, you may take M1, M2 and R square common in all the things. M1, M2, R square. Then one M2 will remain here and one M1 will remain here. That is equal to M2 plus M1 divided by M1 plus M2 square. Denominators are same. That is M1 plus M2 square. Okay. Then one M1 plus M2 gets cancelled with one M1 plus M2. Then you are going to get M1 M2 R square divided by M1 plus M2. Then we will written as I equal to mu R square. Suppose this is equation 6, where mu equal to M1 M2 divided by M1 plus M2, which is reduced mass, Now let us derive the expression for the kinetic energy. Suppose V1 and V2 are the linear velocities of M1 and M2, then kinetic energy T equal to 1 by 2 M1 V1 square plus 1 by 2 M2 V2 square. Suppose this is equation 7. In general, in general, if V is velocity, it may be resolved along x, y, z axis, then V square equal to Vx square plus Vy square plus Vz square, which may be written as dx by dt and its square, dx by dt velocity along x-axis, then dy by dt square and dz by dt square. In that way, the velocity square of mv square. Okay, we want to express them in this way. Now, in the polar coordinates, y equal to sin theta sin phi, and this is x sin theta cos phi, and z equal to r cos theta, means polar coordinates are r, theta and pi. Thus x, y, z axis may be converted into this. Then the velocities become, and the velocity is nothing but dx divided by dt square along x axis, this is y axis along z axis. Then if you transfer them into r, theta, pi, we are going to get, when Cartesian coordinates are converted into polar coordinates, we are going to get v1 square equal to r1 square d theta divided by dt square plus sin square theta d pi by dt square. Okay, here d theta by dt, it is the angular velocity and these are the linear velocity, and similarly v2 square equal to r2 square and d theta divided by dt square plus sin square theta and d phi divided by dt square. In this way, the velocities may be transferred into the angular velocities. Okay, then we know this is angular velocity is represented by omega. v1 square equal to r1 square omega square, and v2 square equal to r2 square omega square. Here, in the both cases, the angular velocities are same. Means they are rotating with the same angular velocity remains same. Suppose this is 8, equation 8. Now we may substitute this in the equation 7. Thus kinetic energy P equal to 1 by 2 m v square, m1 r1 square omega square, and m that is 1 by 2 m2 v2 square, v2 equal to this, that is r2 square and omega square. Okay, thus if we use the reducer mass, that becomes I mu, and the total distance become r square, and omega square. It may be written as 1 by 2 the moment of inertia I and omega square, where mu r square equal to moment of inertia as we have already derived. Therefore, T equal to 1 by 2 I omega square. This is the equation for the kinetic energy in the case of rigid rotator, where mu is the reduced mass, r is the total distance between them, and omega is the angular velocity. Omega is the angular velocity. Thus finding the wave equation in spherical coordinates is 1 divided by r square dou r square divided by dou r dou psi divided by dou r, first term. Then second term, 1 divided by r square sin theta dou sin theta divided by dou theta, then dou psi divided by dou theta. This is second term, plus 1 divided by r square sin square theta dou square psi divided by dou pi square plus 8 pi square m e minus v divided by h square psi is equal to 0. This is equation 9. For rigid rotator, R is constant and dr 0, change in radius becomes 0, v also 0. Then the first term is eliminated. Then when it is rotating, about fixed axis, say z axis in xy plane, then theta is constant, and d theta is 0 and theta is 90 degree, so that sin square theta is equal to 1. Then the equation becomes, equation 9 becomes equation 9 becomes 1 divided by r square sin square theta and dou square psi divided by dou pi square plus 8 pi square m e divided by h square psi is equal to 0. And another thing, when d theta is 0 means 90 degree. D theta is 0 is a constant means when theta is constant, that is theta equal to 90 degree, then sin theta becomes equal to 1, or sin square theta becomes equal to 1. Then equation 9 becomes suppose this is equation 10, then equation 10 becomes dou square psi divided by dou pi square plus 8 pi square m r square divided by h square psi equal to 0, that is dou square psi divided by dou p square plus 8 pi square I, we may substitute m r square equal to I divided by h square, and E is there, E psi equal to 0, that is E psi equal to 0. So this is equation 11. By substituting 8 pi square I E divided by h square equal to 1 m, a constant. Yes, sir. We get that an equation is dou square psi divided by dou pi square plus m square psi is equal to 0. So this is the equation. Now the solution of equation 12 is psi equal to 1 divided by root 2 pi then e raised to I m phi, where m is a constant having the values, where m is equal to 0, 1, 2, 3, etc. Suppose this is the equation for the rigid rotator along one axis. Equation 13 is the equation for a rigid rotator rotating about a fixed axis, that is z axis, along in a xy plane. Here the values of m are the eigenvalues. The values of m are 0, 1, 2, 3, etc. are the eigenvalues. On the rearrangement of the above equation, we get m equal to, that is, we have substituted m equal to 8 pi square, that is m square equal to 8 pi square I divided by h square. Then we can rearrange this E equal to m square h square divided by 8 pi square I into, that is, this is the energy, where m equal to 0, 1, 2, 3, so on. That is which is equal to 1 by 2 I omega square. Suppose this is equation 14. Means this indicates the energy levels of the rigid rotator along the axis in a fixed plane. Now let us study about the application of coordinate equation to rigid rotator rotating in space. Means three axes, means both theta and pi are varying. For rigid rotator, R equal to constant. Then dr equal to 0 and v equal to 0. Then and both theta and pi are varying. Then the equation 9 becomes 1 divided by r square sin square theta dou by dou theta of sin square theta dou psi by dou theta plus 1 divided by r square sin square theta dou square psi by dou pi square plus 8 pi square m e divided by h square psi equal to 0. Then now on rearranging we get plus 8 pi square I e divided by h square psi is equal to 0. Suppose this is equation 16, where I equal to m r square. The solution of this equation, this equation is 8 pi square I e divided by h square is equal to L into bracket L plus 1. That is, it can be rearranged as E equal to h square into L into bracket L plus 1 divided by 8 pi square I, where L is known as rotational quantum number. Number having values L equal to 1, 2, 3 and so on. Suppose this is equation 17. Now the equation 17 may be written as E equal to beta H L into L plus 1, where beta equal to H divided by 8 pi square I, which is known as rotational constant. Rotational constant. Rotational constant. We know E equal to H nu. And the total energy is expressed in nu, then equation 18 becomes nu equal to beta into bracket into L into bracket L plus